When we look at this question, we identify and understand that the 3 points which we are discussing are, what are they? X, Y and Z. We need to identify and understand whether these points are collinear, and if they are collinear, then we need to also state which point is between the other two. But how do we decide whether the points are collinear? We know the trick, we know the way to do it. What is that? First, we pick up the bigger distance, keep it aside. The two smaller distances, we are going to add them up. So which are the two smaller distances? There's distance between y and z and distance between x and z. Add them up, take the sum. So we write distance between y and z plus distance between x and z. It is 7 plus 8. How much is that? 15. Beautiful. And that's our result number 1. Now, pick up the longer one, which is that distance between x and y. We write that. That is equal to 15. That's our result number 2. Observe result number 1 and result number 2. What do we observe? The distances, that is equal. That means we can say from 1 and 2, distance between y and z plus distance between x and y is equal to distance between x and y. This is very important. We wrote this. That means we are saying that there is collinearity between these 3 points, x, y and z. That is clear. But the next question is, we need to identify which point is between the other two. How do we do that? It's simple. There are 2 ways. Either pick up the longer distance. What is that? The points here are x and y. And what is the point missing? The point which is there, the third point is nothing but z. That means z is between x and y. That's the way we do it. Or the other way is, look at the smaller distances. What is common in both? Common in both is z. That means we understand that z is between x and y. That's the way. If you want to understand the same condition diagrammatically, it goes like this. X and y, they are the end points and z is between them. That is why we get distance between x and z plus distance between z and y is equal to distance between x and y. Hence we say that there is betweenness. And what is the betweenness? Z is between x and y such that x dash z dash y. That's how we write. Easy. Very easy, right? Let's look at another sum. Here again we have 3 distances. And what are the points we are talking about? The points are D, E and F. First, let's check whether these points are collinear. Let's do that. Pick up the 2 smaller ones, add them up. So what is that? Distance between D and E plus distance between D and F. That is nothing but 5 plus 6. How much is that? That is 11. And that's our result number 1. Now the longer distance, which one is that? 8. Write it here. And that's our result number 2. Beautiful. We got that. Observe this 2, result number 1 and result number 2. Are they equal? Right inside 11, 8? No. That means from 1 and 2 we come to know that distance between D and E plus distance between D and F is not equal to distance between E and F, isn't it? That means, do we have collinearity here? Do we have betweenness here? No. So hence we write the final statement here that betweenness does not exist between the points D, E and F. Very easy, right?